Hi boys and girls. Today's video is going to cover the practice problems that I expect you to be able to do at the end of section 3.2. All right, these first problems here, basically they're asking you to tell whether or not these things are functions. And if you'll recall from the original video, I told you that as long as every x has only one y, it's a function. It doesn't matter if two x's go to the same y, that's okay. So here, every x maps to exactly one other number. So number one, yes, it is a function. Number two is also a function. Yes, I know that -3 and 2 both map to 1, but that's okay. -3 only maps to 1, and 2 only maps to 1. So that's a function too. Number 3 is not a function because 4 maps to 2, and then it also maps to 5. All right. Looking down here at these little tables that we have, let me move this up a little bit. What you're looking for is repeated x's. You don't care if the y's repeat. That's not of interest to us. We're looking for x's that repeat. Because there are no repeating x's, this is a function. Each x has only one outcome. But when you look at number 5, notice that here's a 5 and here's a 5. Here 5 becomes -3. Here 5 becomes 2. That makes that not a function. All right, each x must have only one result, one y result. So over here again, we're looking for duplicates in the x column. We have 2 3s. This 3 maps to 7 and this 3 maps to 5. Not a function. Same thing with these. You want to know if they're functions, but now it's a little harder. It's not so laid out. You're looking at the x values and you're looking for duplicates. I see 2, 4, 3, 5, and -2. There are no duplicates for 7, so 7 is a function. Number 8, 6, I see 2 6s. Here 6 maps to -1, here 6 maps to 5, not a function. Number 9 is just your typical linear equation. All lines are functions except vertical lines. This is not a vertical line. A vertical line would be x equals some number, like x equals 5 or x equals 10. That would be a vertical line. This is not a vertical line, therefore this is a function. Y equals 11 is a horizontal line, which is totally a function. It would pass the straight line test, or the vertical line test, I guess they call it. When you're looking at graphs, the vertical line test is your go-to here. I'm going to use the graph to make it as vertical as possible. All right, there we go. So think of the, no, what you doing there? Don't do me like that. No. Okay, I want to pick you up and move you. You stupid line. What is wrong with you? All right, let's just get rid of it. Try it again. Maybe what I shouldn't have done is I shouldn't have put it right on the shape. Put it next to it so I can kind of tell if it's a vertical line or not. Okay. There we go. Now let's see if this works. Oh my gosh. What a stupid line. Why is this not working? I don't know. Okay, well, let's imagine we have a vertical line. Yes, let's do that. Imagine a vertical line. Another thing you can do with these graphs is every one of these grid marks is a vertical line. Now imagine moving your pencil over this. At no point will this intersect this line at 2 places. And again, I told you that every straight line, with the exception of a vertical line, is a function. So number 11 is a function. Now number 12, you've got to check and make sure there's not more than one dot on a vertical line. This vertical line here has 2 dots. That makes it not a function. Think about it. That means for the x value 2, you have 2 results. You have +2 and -1. So that is not a function. And number 13, the vertical line test also causes this to fail because you can see a vertical line intersects the graph at 2 places. 13 is not a function. All right, so Now this becomes a little tedious. The cost for each car entering President George Bush Turnpike at Beltline Road is related to the number of cars entering the turnpike at Beltline Road. The costs of different numbers of cars entering the turnpike at Beltline, how many times do we have to say Beltline Road, are as follows. 1 car, 75 cents, 2 cars, $1.50, 3 cars, $2.25, 4 cars, $3, and 5 cars, $3.75. Make a table. Make a table. All right? Make a table. All right. Oh boy. This is going to be number of cars, and this is going to be money. All right. So 1 car, 75 cents. 2 cars, $1.50. 3 cars, $2.25. 4 cars, $3. 5 cars, $3.75. Check. Determine the domain and the range. Domain is your x values. The domain is 1, 2, 3, 4, and 5. Range is your y values. 75 cents, $1.50, $2.25, $3, and $3.75. Determine whether or not it's a function. There are no duplicates in the x column, so this is a function. All right, I have another one like that. Yeah, we do. Okay, the average value of a house changes over time. The values of a house in January in Denver, Colorado for different years are as follows. 2014, 2015, 2016, 2017. Make a table. Let's see if I can make a better table. It's so hard with this drawing tablet. Okay, so we'll put year and price. So in 2014, the home price was $254,000. I hear Colorado's kind of pricey. 2015 is $293,000. Be interesting to see these numbers in Ohio also. $338,000, and 2017 is $372,000. All right. Determine the domain and the range. Okay. Domain is 2014, 2015, 2016, and 2017. The range would be the home prices. I'm going to shorten this. 338,000 and 372,000. Is it a function? Well, I don't see any duplicates in the x column, so yes, it's a function. Okay. Now we're getting to finding the value of a function. This is where we were substituting values and finding out what the function would be equal to for various values. How come those are not attached to each other? That's weird. Okay, so if f of x is 3x plus 2 and g of x is x squared minus x, find each value. Okay, so here we have f of 4. So we're going to be using the f of x equation, not the g of x. When we get to the g's, we'll use the g of x. Okay, so we're just using this 3x plus 2. So this would be 3 times 4 plus 2. We substitute the 4 for the x. This would be 12 plus 2, which is 14. If x was 8, it would be 3 times 8 plus 2. 3 times 8 is 24, plus 2 is 26. And then we substitute negative 2. We would have 3 times negative 2 plus 2. Multiply first. 3 times negative 2 is negative 6. And negative 6 plus 2 is negative 4. Pretty straightforward. Alrighty, now these are g's, so we're going to be using the g of x equation. All right, notice that the letters are g's here. So we have x squared minus x, so we would have 2 squared minus 2 which is 4 minus 2, which is 2. We would have negative 3 squared minus negative 3. Negative 3 squared is positive 9, and minus a negative is the same as adding a positive, and 9 plus 3 is 12. Next, we have negative 6, so we have negative 6 squared minus negative 6. Negative 6 squared is 36. This is the same as plus 6 equals 42. All right, now they're getting a little more in depth here. They're going to have you do additional things in addition to substituting. See here, this first one, they want you to substitute 2 for x, and then they want you to add 1 to the equation. So if we substitute the 2 plus 2, then we have to also remember to add on an extra 1. Okay? 3 times 2 is 6, plus 2 plus 1 is 9. This will be f of 1 minus 1, okay? So we're going to substitute, and using the f of x equation, we're going to substitute, well, we got the 3, substitute 1 and plus 2, that's the equation, that's this part right here, and then we have to remember to subtract 1. 3 times 1 is 3. 3 plus 2 minus 1 is 4. And here we're going to use the g of x equation and substitute 2. So it will be 2 squared minus 2. And then we have to subtract, oh, I said 2 and I wrote x. Yeah, no, it's early. Minus 2. And then we have to remember, for this one, we're going to subtract an additional 2. So subtract 2 more. So this would be 4 minus 2 minus 2. I think we know where that's going. Right. And no, I didn't have these moved over more. Okay. So for this one, but they're getting a little more in depth, but this is basically all I'm asking of you in this section, is to be able to say, yes, it's a function, or no, it's not a function, and to be able to find the value of a function. All right, so we wanted a g of negative 1 plus 4. So we would use the g of x equation, substituting negative 1 for x, and then we have to add 4. Negative 1 times negative 1 is 1. Minus a negative is the same as adding a positive. Plus 4 is 6. Here we have f of x plus 1. All right, so we're just going to leave x. We're not going to substitute x. We're just going to leave x. We're going to have the 3x plus 2, but then we have to add 1 to it, which gives us the equation 3x plus 3. That's as simplified as you can make that one. Here, we're substituting 3b for the x in the g equation. So we're using the g equation, and everywhere there's an x, we're going to put 3b. So we will have 3b squared minus 3b. Interesting. Well, 3b squared, when we distribute this, we're going to raise both of these to the second power. So that's going to give us 9b squared minus 3b. And that's basically all we can do there. B squared and b to the first are not like terms and cannot be combined. So that's as simple as that one gets. 9b squared minus 3b. And it's totally cool to leave your answer that way. You don't know, they're asking you to work with a variable, not telling you its value. So that's the best you can do. All right, I think this is going to be the last one I'm going to do from this section. Many cell phone plans have an option to include more than one phone. Right? The function for the monthly cost of cell phone service from a wireless company is f of x equals 25x plus 200, where x is the number of phones on the plan. Find and interpret f of 3 and f of 5. Okay, so they want you to find the cost for 3 phones or 5 phones. So we will do 3 first. We're going to have 25 times 3 phones plus 200. Must be like their monthly rate. 25 times 3 is 75 plus 200. So it would be $275 a month for the plan with 3 phones. What about 5 phones? All right, now that everybody's got to have a phone, even my grandsons, they're like 4 and 6, they have phones. We're going to substitute 5 this time for x. 25 times 5 is 125. And that gives us $325 a month if you have 5 phones. Okay. That's all I'm planning to do for today. That's basically what I expect you to be able to do. So if you feel okay about this, go on over to McGraw-Hill and complete the 3-2 practice assignment. As always, if you have any questions, shoot me an email, raise your hand, just ask. Have a great one.